equations of lines or equations of straight lines. So in this video we are going to see how we can find an equation for a straight line, and in fact what sort of equations arise as equations for straight lines, or which are simply called lines. So in the very beginning we look at the simplest case, namely lines that are parallel to the x-axis, that is horizontal lines, and lines that are parallel to the y-axis, that is vertical lines. So say we have a point A on the x-axis, which of course is a real number that corresponds to a point on the x-axis, and we draw a vertical line through that point. In fact, let me just draw a small figure here. Say this is our x-axis and we have a point A here on the x-axis, and through this point we draw a vertical line. Then on this vertical line, if we arbitrarily choose any point, then the x coordinate of that point is A. Y coordinate may be anything. In fact, the y coordinate will depend on where the point lies on this line. The y coordinate for this point the y coordinate is say y. For this point the y coordinate will be something else, which will be a real number smaller than y, because the point lies below that point which is lying here. But the thing to be noted here is that the x coordinate is constantly A, and it does not depend on where you choose the point on the vertical line. The x coordinate is constantly A. That is why x equal to A is an equation of this vertical line. See, x equal to A is an equation of the vertical line that passes through the point A, which is on the x-axis. Similarly, if we consider the y-axis, on which say we have any point B, and we consider the horizontal line that passes through, let me write y here, represents that this is the y-axis, and we are now considering a horizontal line passing through B, which is parallel to the x-axis. Then on this line, if we, just like that case, if we now arbitrarily choose any point, then for that point its x coordinate is it will entirely depend on where the point is on this line, but the y coordinate is constantly B, because that's what the situation is. You see, the B is here, so on this level all the points will have its y coordinates constantly equal to B. Here you may have another point with a different x coordinate but the y coordinate is B. Here the x prime, that coordinate is greater than x because it lies to the right of x. So for this part of horizontal lines, y equal to B is an equation, because it represents the fact that on this line y is constantly B, that is the second coordinate of any point is constantly B. And this example illustrates this situation in a concrete case. Say we have the point 2, 3. Let me wrap these things up. We have the point 2, 3. Now we can draw a horizontal line passing through 2, 3, which in fact is also a horizontal line passing through the real number 3, or the point 3 on the y-axis. Its equation is y equal to 3, because on this line y is constantly 3. For any point the second coordinate or the y coordinate is constantly 3. Similarly, if we draw a vertical line passing through this, then it's also passing through the point 2 on the x-axis, and its equation is x equal to 2. On this line, any point has x coordinate constantly equal to 2. Now these are vertical and horizontal lines. Now if we consider a non-vertical line, that is a line for which is like this or this, for which there is a slope. Recall, we have already discussed before that vertical lines are lines which don't have slope. The notion of slope is undefined for them. That's because if you try to form the ratio, then the x increment along that line is 0. So you cannot divide by delta x to find the slope of such a line. Other than that, if you consider non-vertical lines, they have slopes. Now, how can we write an equation for such a non-vertical line? Let's see. We can write an equation for a non-vertical line if its slope m is given and it is known that it passes through a point, say P1 x1 y1, whose coordinates are x1 y1. If these two pieces of information are given to us, then we can write an equation for that line. In fact, we can give a name to the line. Line say L. If Px, y is any point on L other than this point, then we already know that if two distinct points are given to us on a straight line that is non-vertical, then we can calculate the slope of the line by dividing the y increment by the x increment. Y minus y1, this is delta y, and x minus x1, this is delta x. The fact that L is non-vertical makes the line either like this or this. In any case, if it is like this or this, and no matter how steep the line is, you will either have this point here and this point here, or this point here. These are two cases, okay. The P will either lie above P1 or below P1. Here also similarly, P will lie either above P1 or below P1. Note that because the line is not vertical in both the cases, so x1 can never be equal to x in both these situations. For that to happen, P1 and P should lie on the same vertical line, and that is not possible because the given line itself is not vertical, and that's why, because x and x1 are different, so this is never equal to 0. The denominator is non-zero, and because of that we can form this ratio. And from this we can, this itself is an equation for such a line L. We can rearrange the terms of this equation slightly to make it look somewhat better, or y minus y1 equal to m times x minus x1, or in fact we can also write y equal to y1 plus m times x minus x1. So this is an equation for the non-vertical line L, and based on this observation we have the definition. Next definition. The equation y equal to y1 plus m times x minus x1 is it has a name, it's the point slope equation of the line. Is the point slope equation of the line having, or since we are writing point slope, so let me maintain that order. Equation of the line passing through the point P1 x1 comma y1 and having slope m. Okay, so to write an equation for this line, we need its at least one point through which the line is passing. Note that this P1 itself may be chosen to be any other point. At least one point we need, and we also need its slope. The sign of the slope will tell us whether the line rises upward as we go to the right side of the x-axis, or it falls downward when we go to the right side of the x-axis. If m is positive, then the line looks like this. If m is negative, then the line looks like this. And the value of m, the absolute value of m, tells us how steep the line will be. If we have very high value of m, it will be steeper and it will be very steep. If we have an even higher value of m, it will be even more steep, but it will never be vertical. Okay. Small value of m indicates that the line is not very steep. Okay, it's not very different from the x-axis, in a sense that it can be obtained from the x-axis by applying a small rotation, and that's why we call this equation the point slope equation of the line passing through such a point and having slope m. This name indicates what we need in order to be able to write the equation from the line. Example 7. write an equation. Okay, so it has been given as a question. Write an equation for the line passing through the point two comma 3 with slope minus 3 by 2. So slope minus 3 by 2 means it will be a line which will look like this, and it also has to pass through the point 2 comma 3. We can write a sort of solution to this problem. Such a well, we should not write such a line, should write the line because it's a fixed line. Has equation. Now that we know exactly what the equation is, we can directly use the values to write it. Y equal to y1 plus m. M is minus 3 divided by 2 times x minus x1. Okay, so this will be minus 3 by 2x. It will stay like that, and along with that 3 minus minus will be plus, 2 will cancel out, 3 plus 3 6. Okay, so this is an equation of the straight line that passes through the point 2 comma 3 and it has slope minus 3 by 2. Example 8. Write an equation for the line through these 2 points. Okay, now instead of a point and a slope, we are given 2 points on the line. But if 2 points on a non-vertical line are given, then of course we can use them to find the slope, and then we can write the equation. That's what we are going to do. Write an equation for the line through minus 2 comma minus 1 and 3 comma 4. The slope of the line is, we can directly calculate the slope using these 2 points. Y increment y minus minus 1 divided by x increment 3 minus minus 2. So that means 5 divided by 5, so this is equal to 1. If you are wondering which coordinates should appear here, that is, which point should you consider as the final point, I mean you are talking about increment, so there is a motion involved. That's how we defined increment. I mean, that is not exactly how we defined increment, but increment, the notion of increment has arisen from the motion of a particle in the two-dimensional plane. If you think of this as the final position of the particle and this as the initial position, then this is how we will calculate the increments, and that's how we will calculate the slope. But if someone wants to consider this as the final position and this as the initial position, will that person get another value? No, because you see, instead of this, if you calculate -1 -4, that is, you are, instead of subtracting -1 from 4, you are subtracting 4 from -1. Similarly, in the denominator, you are subtracting 3 from -2. Then you get -5 divided by -5. Still you get 1. So it does not matter which way you go, which one of the 2 points you consider to be the final position of the particle or the final value of x. When we are calculating, say for example, the increment in x, then if 3 is the final value and -2 is the initial value, then the increment is 3 minus -2. And if you are considering -2 as the final value and 3 as the initial value, then the increment is -2 -3. Note one thing carefully, that the increments are not equal. Here the increment is 5, here the increment is -5, but the ratio of the x and y increment, or rather y and x increment are equal, and that's what the slope is. Okay, now we have another I should not say ambiguity, but there are still 2 more ways of calculating the equation of the line. Fine, we have got slope and the line passes through this point as well as this point. Which one should we choose for writing the point slope equation of the line? Let's first use this point and then use this point and see whether we get different equations. If we get different equations, then there is a problem, because then if the equation of the line depends on the choice of the point x1 comma y1, then it will vary. If you take different points on the line, you will get different equations. That should clearly not happen, because there is a single line, you should get one equation, and in fact that's what we get. So let's just see the calculation. Yes, I can write like this: the line passing through this point with slope 1 has equation y equal to -1 plus 1 times x, okay, x minus x1. x1 is -2, or x plus 2. -1 plus x plus 2, that means x plus 1. So this is one equation for our line. And now if we use the other point, what shall we get? the line passing through 3, 4 with slope 1 has equation y equal to 4 plus 1 times x minus 3, and you can see that we are again getting x plus 1. So yes, the equation stays the same as it should be. Okay, now we come to the notion of intercepts of a line. Should I say x-intercept first? Okay, the x coordinate of a non-horizontal line no, it does not make sense. X coordinate of the a line does not have x coordinate. The x coordinate of the point where a non-horizontal line crosses the x-axis is called the x-intercept, CEPT, of the line. I need ink. Similarly, the y coordinate of the point where a non-vertical line crosses the y-axis is called its y-intercept. Instead of using slopes and points through which a line passes, we can also use the notion of intercepts, x-intercept and y-intercept, to write an equation of a line. So what is this thing saying? Say we have the x-axis and we have a non-horizontal line. If we have a non-horizontal line, then no matter how the line is situated and how tilted the line is, at some stage it will cross the x-axis, and this point of intersection of these two lines, x-axis and this non-horizontal line, it will have an x-coordinate and a y-coordinate of course also. This x-coordinate is known as the x-intercept of this line. Just like that, say this is the y-axis and we have a non-vertical line. This non-horizontal line can either be like this or this, but you can understand that it will always intersect the x-axis, and the point where it intersects the x-axis has an x-coordinate that is known as the x-intercept of this line. Now if we have a non-vertical line, it's not like this, then that line also crosses the y-axis at some point. That point has some y-coordinate. That y-coordinate is known as the y-intercept of this non-vertical line. It can be like this also. A non-vertical line whose y-intercept is b passes through the point 0, b. That is because you see y-intercept is b means it crosses the y-axis at this point, where the x-coordinate of course is 0. Oh, there I said the x-coordinate can be anything. In fact, I did not say anything about the x-coordinate, fine. So the x-coordinate is 0 and the y-coordinate is b. Okay, so such a line having y-intercept b must pass through this point. And now additionally, if we know the slope of that line, then we can clearly write its equation. If m is the slope of the line, then its point slope, let me keep this, equation is y equal to b plus m times x minus 0, or y equal to mx plus b. So you see that unlike the point slope, general point slope equation of a line, of a straight line whose slope is given and a point is given through which it passes, here you can write the equation of a line having slope m and y-intercept b more directly. You don't have to calculate anything, you just look at the values and you put them here and you get the equation. Okay, it's more direct. And in fact, one can use both the intercepts to write the equation of a line, which however is unfortunately not given here. Anyway, let me just show the intercepts of a line. A line that is neither horizontal nor vertical, it then will have both x-intercept and y-intercept. that line may be like this, it may also be like this. Let's see this case itself. So the line is crossing the x-axis here at this point and the y-axis at this point. So if this point represents the real number a and this point represents the real number b, then the x-intercept of this line is a and the y-intercept is b. You can, if you want, from the information that the line is passing through these 2 points whose coordinates are known, the coordinates of this point are 0, b, and the coordinates of this point are a, 0. You can write the equation, in fact the point slope equation of this line, and you will see that the equation comes out in a particular form. You please do this, okay? You find what are the things you have to do here. Using these 2 points, you find the slope of this line, and then using that slope and any one of these 2 points, we have already done one such example. I think it's example 8. Yes, just like that, you find the equation of the line and see how that equation looks. Such an equation is known as the equation of a straight line in intercept form, where both x and y intercept have been used. It's not given in this book. It's not needed, I think. So this particular form of the equation prompts the next definition. The equation y equal to mx plus b is called the slope-intercept equation. Of the line having slope m and y-intercept b. Example 9. The line y equal to 2x minus 5 has slope 2 and y-intercept minus 5. That means that particular line will look like this. The point where it will cross the y-axis will be 0, minus 5. It will be a point below the x-axis, and its distance from the x-axis will be 5. And the value 2 determines how tilted it is. The equation ax plus by equal to c, where a, b and c are real numbers and both A and B are not equal to 0 is called the general linear equation. In the two variables x and y. And it represents a line, and the reason for calling it the general linear equation is this, because the graph of such an equation is always a straight line. And conversely, every straight line has an equation of this form. This form means this form. I leave it to you to figure out that these remarks are true. Namely, that if you draw the graph of this general linear, this equation that we are calling a general linear equation in x and y, you will get a straight line. To see that, in fact, let me just tell you why that is true. It's not that it's given that both A and B are not equal to 0. So suppose B is 0. So two cases arise. B is equal to 0 and B is not equal to 0. If B is equal to 0, then because A and B can not both be 0 at the same time, in this case A is not equal to 0. And what will the equation be in this case? Ax equal to c, or since A is non-zero, the equation can be written as x equal to c by A. And we have already seen that this represents the straight line that is vertical, and it crosses the x-axis at the point which corresponds to the real number c by A, or in other words, it crosses the x-axis at the point whose coordinates are this. Okay, so that means it's a straight line. Now the second case, where B is not equal to 0, we can rearrange the equation like this: by equal to minus ax plus c, and because B is non-zero, we can write minus a by b x plus c by b. And from the form of this equation, you can see that this is the equation of the straight line, the the slope-intercept equation of the straight line, whose slope is minus a by b and whose y-intercept is c by b. So this just shows that such an equation always has its graph a straight line. Now I want you to convince yourself that the converse is also true. Namely, all the straight lines you have seen, in fact their equations you have seen, all of them are of this form. For some A, B and C, where both a and b are not equal to 0. Okay, this you do. I should have added one more thing, including lines with undefined slope, that is vertical lines. We have already seen when vertical line appears, precisely when b is 0. Then example 10. Find the slope and y-intercept of the line. Okay, this is quite easy. Eight x plus 5y. So this is an equation given in the form of a general, although it's not general, it's a particular linear equation, but still it's of that form, equal to 20. We can write the given equation as this: y equal to minus 8 by 5 x plus 20 by 5. So what we have done, we have added minus 8x on both sides, and then we have divided both sides by 5. Or we can simplify a little bit more, plus 4. So the slope of the line is minus 8 by 5, and its y-intercept is 4, from which we can, in fact, without, if someone asks you to draw the graph of this equation, you can recognize from the form of this equation that it is going to be a straight line, and from the additional information that this is the slope and this is the y-intercept, you can directly draw the graph. Then example 11. Lines through the origin. How do equations of lines that pass through the origin look like? Lines through the origin have equations of the form y equal to mx. Why? Because you see, if this is our x-axis and y-axis, then if a non-vertical line is passing through the origin, either like this or like this or like this. Okay, I think I have messed up. It's not really, you can understand all of these are supposed to pass through the origin. Then all of them have y-intercept equal to 0, because this is the point where they are crossing the y-axis, so which corresponds to the real number 0. So all of them have y-intercept 0. M of course will denote the, M is the slope of the line. So by the slope-intercept form, its equation will be y equal to mx plus y-intercept, which is 0. So that's why y is equal to mx. Note that we have considered non-vertical lines. Among them, the horizontal x-axis is also included. But what about the x-axis itself? The equation of the x-axis we already know is x equal to 0. Oh, I think they have not equation of the y-axis is x equal to 0. So that thing, however, is not an equation of this form. So we should add the extra condition that non-vertical lines through the origin have equations of this form. Am I saying it correctly, or have I missed something? For non-vertical line, this is the form. Okay, there is no doubt about that. For the y-axis itself, this is the equation, because on the y-axis, the x-coordinate of every point is 0. So yes, we need to mention non-vertical. Non-vertical lines through the origin have equations of this form. Okay, now finally we come to the question of why we need straight lines. From an application point of view. So the next thing is applications, the importance of lines and slopes. When you hear the word line, in general it does not represent a straight line. It can be a curved line also. However, in the context of this section, line means straight line. Okay, so here are some words from the author. Light travels along lines, straight lines, in ordinary circumstances. In extreme circumstances, that's not necessarily true. Light travels along lines. As do bodies falling freely, this is true. So far I know this is always true. Falling freely in a planet's gravitational field or coasting under their own momentum. It's the situation of Newton's first law. No force is no external force is being applied on the body, so it continues to move and maintaining its own momentum. Although this cannot be achieved on Earth due to several you cannot easily create a situation which is perfectly forceless. Gravity is always there, and that friction is always there. You can, at most what you can do, you can try to minimize friction as much as possible. And in fact, this is one example. Like a hockey puck, ice hockey puck, gliding across the ice. Still there is friction, but the friction is very small. For a considerable length, it will look as if the ice puck is moving with its own momentum without any sign of stopping, but eventually of course it will stop. We often use equations of line to study such motions. Also known as linear equations to study such motions. For this, you look up rectilinear motion in physics. Besides this, many important quantities are related to each other by some sort of linear relation or linear equation. So if we know that the relationship between two quantities is a linear equation, we can find the equation from two pairs of corresponding values of the quantities, just like we find the equation of a straight line from the coordinates of any 2 points on it. This we will illustrate in the last example. Additionally, slope is important because it gives us a way to say how steep something is. Yes. A way to say how steep something is, and that something can be a plane or a roadbed or some or a roof of some house, things like that. Roadbeds, roofs, stairs. Etc. And at the same time, slope also tells us how rapidly something is changing. If the slope of a line is very high, say it is going like this, or it's dipping down like this, then the x and y coordinates of the points on that line, of course they are related by a linear equation, and they can be thought of as two variables which have a linear equation relationship between them. It tells us that as you change x, say the line is like this, your x is changing along the x-axis. If your point is here and you consider another point, then there is not much change in the x coordinate. Along the x direction there is not much change, but y has changed significantly, y has increased. If it is steeper than this, then this increase will be even more for that same change in x. Now y changes much more. If the slope is small, then for a significant change of x, y will change only slightly. So the slope gives us a way to say how rapidly things are changing. And since calculus is the mathematics of change, so naturally slope will be important. Plays a significant role in calculus. Okay, now finally let us see two physical quantities which are related to each other through a linear equation, our last example in this section. And it's related to these two scales of measuring temperature of a body, Celsius and Fahrenheit. Celsius versus Fahrenheit. The Celsius temperature, or in fact we can same thing, whether we say Celsius first and Fahrenheit afterwards, it does not matter. Fahrenheit temperature, which we will denote by F, say, of something, of some body, and Celsius temperature of the same object are related by a linear equation. That's a fact. Linear equation means we can write it in slope-intercept form. Of the form F equal to mc plus b. M is the slope, b is the y-intercept. Now this is what is true, and it can be found from experiment, that the freezing point of water is 32 degree Fahrenheit or 0 degree Celsius, and the boiling point of water is how much? 212 degree Fahrenheit, or the Celsius temperatures are much easier to remember, 0 and 100. So you see that on the graph of this equation, which is of course going to be a straight line, these are 2 points, this and so we have got 2 points on the graph. Using them we can find the values of m and b, and thereby we can find the equation or the relation between Fahrenheit and Celsius temperatures. This is what the author means when he is saying that if two quantities are related by a linear equation, then we can use two pairs of corresponding values of those quantities to find the equation. Okay, that's what he meant. This is one example of that. So that means when f is 32, then c is 0, and when f is 212, then c is 100. These imply we can solve these two equations. From the first one, we are directly getting the fact that b is 32. Now, if we substitute that value of b here, then we will get m equal to 212 minus 32 divided by 100, or 180 divided by 100, or that is equal to 9 by 5. So f is equal to 9 by 5c plus 32. You either write the equation like this, or you can also write c in terms of f. Or c will be equal to 5 divided by 9 times f minus 32. So this is how the Fahrenheit temperature and the Celsius temperature of some object are related through a linear equation. So here the section ends. Section end means all the things end except the exercises at the end of the section, which we will start solving in the next calculus video. So with this I end this video. I encourage you to write in the comment section whatever you have, whatever thoughts you have about these things. If you have any doubt, if you want these things to improve in some way, you can write in the comment section. So I sign off for tonight. This is me, Lucifer, from a mathematical room. Have a nice night.